Good afternoon, ladies and gentlemen, and boys and girls. This afternoon, I'm going to present to you surface area and volume of 3D objects. I'm Mr. Rantene. I'm responsible for mathematics in the province. Right, the 3D object that we are going to be dealing with this afternoon is the rectangular prism. The picture that we see here is just a representation of the rectangular prism. You can see the microwave there, the books, fish tank, and you can see all those pictures that are there. They are just a representation of the rectangular prism. But the objective of this afternoon, you're going to use appropriate formula and conversion between SI unit to solve problems and calculate the surface area of rectangular prism, triangular prism, and cylinder. But this afternoon, we are going to focus only on the rectangular prism. Right. These are just the examples of the questions that may be asked. It's just an example that I took from annual national assessment question paper. As you can see, the first one that is here, it is just a second. I want to get the point here. Right here, as you can see, it's a rectangular prism. You get it has got all those dimensions, but in this case, they're looking for the volume. You get when they talk about the surface area, these are type of question that they give. Look at this one, this that again is a compound figure. You have to find the surface area, also find the volume. Here, this is a rectangular prism, this is the cylinder. These are some of the questions that you get that are related to the surface area and volume. Right. Surface area is the total number of unit squares used to cover a 3D surface. This one is a 3D object. Also, these are the examples. Look at a box of match to represent this figure that is in orange. Right. Surface area. What does surface area mean to you? You have to ask yourself. Have you ever had to use it outside the maths classroom? Why should you learn about surface area? Does it have anything to do with what is in the inside of the prism? Well, just think about it. Surface area is found by finding the area of all sides and then adding those answers up. All the sides that you see in that prism, you add the area of them, then it will give you the answer of the surface area. How will the answer be like? Because answer will be in unit squares, whatever unit that has been used. Either if you use meters or centimeters, but it will be in either in centimeter squared or millimeter squared or meter squared. It will depend on the unit that is used, because this is an area. But let's start in the beginning. Before you can do surface area, you have to know the following formula. Rectangle, the area here is it's a breadth multiplied by height. You can say length times breadth, but in this case, we'll be dealing with a breadth, a length in the form of a height. You see the figure how it looks like. Then a triangle area is half base multiplied by height. The area of a circle, as you can see, is pi r squared. Then the C stands for the circumference of the circle is pi multiplied by diameter or 2 pi multiplied by radius. Right, this is an example of rectangular prism. The prisms are 3D objects where two opposite sides are parallel and have the same shape. Look at this, it's the right triangular prism. The triangles there, they are parallel and they are the same. Here is a pentagonal prism. Then you've got the hexagonal prism. Below here, these are rectangular prisms. Our focus today will be on the rectangular prisms. Then the area of the rectangle, if you can see this figure here, it's a rectangular prism. This rectangular prism has got how many faces? They've got 6 faces. The front and the back, left and right, top and bottom. And the height here is given as 5 centimeters. Then here the length 6 centimeters, the breadth can be 4 centimeters. If you have to calculate the area of all these faces, as you can see here, let me start with this one. That I think it is the front one. What is the area of the front one? The area of the front one is 4 multiplied by 5. 4 in front here is multiplied by 5. It will be the same as the back one because they are the same. As you can see here, 4 multiplied by 5 is 20 centimeters squared. That is the front part. Then if you look at the right part would be, I've got here 6 multiplied by 5. This is the right, which is the same as the left. You can see here, 6 multiplied by 5 is 30 centimeters squared. Then last one will be the top part here. On the top, you can see you've got 4 multiplied by 6. 4 here, you can see this red, the red here, mouse here, multiplied by 6 here. This will give you this 4 multiplied by 6 is 24. Then the surface area of the whole, this rectangular prism is, you're just going to add all of them. In other words, you can see here, you've got 24 plus 20 plus 30. Here we have added, multiplied by 2. Why? Because you've got the front and the back, right and left, top and bottom. That is why you multiply by 2 here. Because the opposite sides have equal areas. You can see here, if you add the total here and multiply by 2, it will give you 148 centimeters squared. Don't forget that the unit must always be n squared because we are dealing with the area here. Yeah? Sometimes the question may be given here where you've got the units are not the same. It is important that you must have all of them having the same units. Very important. Another example here, almost the same as that one, that you say, what is very important is you've got 3 steps that one can follow. You always have to know how many faces that the object have. In this case, it's still a rectangular prism, it's got 6. Then step 2, what do? You find the area of each face. Of course, we said that the faces are, opposite faces have the same area. Yeah. Now, let's look at the area of A here, this face A. The area of AC here, look at here, it's got a height of 5 inch. Doesn't matter whatever unit can use there. Then you've got here the length of 4 inch. So the area of A here is 5 multiplied by 4 equals to 20. Because A is the front is the same as the back one. So that is why we have multiplied by 2 here. Because A has got the back part because the front here. So you multiply by 2 to give us 40. Then if you look at the B, it's the top, which is the same as the bottom. So if I calculate here the area of B, it will be the same as the area of B, the bottom part of this B. Okay, because B is the top, then on the bottom is the same, they've got the same area. Here in this case, it's going to be 4 multiplied by 6. 4 multiplied by 6. Look at here, 4 multiplied by 6 will give you 24. Multiply by 2 because I said there are 2 equal opposite sides here for the same area, which is for 48. Then if you look at C is on the right, it's the same as what is on the left. Now. So you are going to multiply 6 multiplied by what's the length here? It's 5, the same as that one, 5 inch. So it will be 6 multiplied by 5 is 30 multiplied by 2. You can see that if you add all of them, it will give you 148 inch squared. So you can see the same as what I've done previously. The only thing is just that they've got different units. Very important, keep to the units. It's very, very important that you have to do that. Yeah. You can see what's important is adding all the areas that you have here. You've got it similar. We are going to use similar formulas that you used to the area of a triangle, area of a rectangle, and the area of a circle. Those are the things that are very important for the surface area. Then we've got another formula that one can use to find the surface area of any prism using the basic formula for surface area. In this case, it says surface area equals to perimeter multiplied by height plus 2 times B. What is B? Is the area of the base. So for any prism, you can use this formula to find the surface area of any prism. Then I'm going to do an example that is using this formula. Let's go back to the same figure, rectangular prism. Just find the first the perimeter. The perimeter is the surrounding part, but this part plus that part at the back part of it, just the perimeter is like a fence, something that's surrounding it. Yeah. So it means perimeter here would be 4 plus 6 plus the back there is 4, then plus 6. Yeah. And if you add all those, it will give you 20. Perimeter is 20 here. Okay, you just adding the length here, not going around the figure. It's 1, 2, just like that. We've got 4 sides. Hence you've got 1, 2, 3, 4. It's 20. The height obviously is this perpendicular height, which is 5 centimeters. The height. Then the base area. The base is how this figure is sitting with this side. Yeah? The area of this side is 4 multiplied by 6, which will give you 24. Okay. Now going back to the formula of the surface area that I spoke about. Surface area equals to perimeter multiplied by height plus 2 times the area of a base. Let's substitute now. What is the perimeter? Perimeter is 20 centimeters multiplied by height. What is height? Height is 5 centimeters plus 2 times the area for base. What the area for base is 24. Yeah? Let's do some calculation. 20 multiplied by 5, it would give you 100 centimeters squared. Then here, 2 multiplied by 24 is 48 centimeters squared. If you add those two together, can you see that it's 148 centimeters squared? So this formula works for any prism that you have. Can use this formula to calculate the surface area. But it is important that you work with the faces and understand how the faces work. Individual faces of the rectangular prism, then add these areas, then it is easy for you. But after understanding that, you can then go to this formula. Remember, this formula is not going to be given to you. You have to know it. Right, you've got also composite figures. Né? Look at how this figure looks like, the combination. Look at this figure. You may be asked to calculate the surface area of this. That is, you have to find the faces. Né? First of all, it's important that you must know the faces. Look at this one. Okay, just make an example in the first figure. Yeah, let's look at the right. Let's find how does it look like on the right hand side. If you look at from the right hand side, it looks like this. Né? Then if you look at from the left hand side, it looks like this. Now it's the view when you view it from the left. Then if you view it from the front, it's like this. Then if you view it from back, this is or top. Look at top, it's like this. Then if you view it from the back, it look almost similar to the front. This it actually show you how it looks like. Then if you look at it from the bottom, this is what you see. Huh? Right, it's very important. Then you can be able to calculate each space or size. Then you can calculate the area. Then you add them together. That will be the surface area of that figure. Right, let's use this one to actually do an example. Let's look at this one. This is how it looks like in the front. This is how it looks like at the back. This is how it looks like when you look at from the right. Let's look at how it looks like from the left. You must always have that view, thinking from when you are on the other side, how this thing, when you look at it, how it would look like. It's very important. Then from the top, is how it would look like from the top. From the bottom, this is how it looks like. So then you can be able to calculate now the area. Look at the area. How many blocks do we have here? 1, 2, 3, 4. 4 units square, right? Then how many here? 4 squares. Then that one is also 4 squares. This one is 4 squares. Then that one is 6 squares. And this one is 6 squares. So if you add all these areas together, it will give you the surface area, which is equals to, you can see that I've added all of them to all these areas together. Then it will give you surface area of 28 unit squares, right? Then these are just an examples of rectangular prism that we found in our daily life. You can see here that that box, kind of a conflict box, then the shoe box here, then you've got the present here. It also represents the rectangular prism. So it's important to see that what you do in mathematics is actually applicable in our daily life, right? Then when wrapping a gift, you are covering the outside of the box. This is another example of a surface area of a rectangular prism, right? Right, again, you can also find the total surface area when you want to wrap a rectangular prism. The same as what I've just indicated. It just is for you. You just think about, take a box and just make measurement there and calculate the surface area. It will tell you the amount of wrapping paper that is required. I think I am done. Thank you very much. Have a beautiful, nice afternoon. Thank you. Mm.